Hi everyone, this is Ike from systemcraftsman.com. A little bit more than a year ago, I had a webinar talk called A Day in a Coffee Shop, Building Event-Driven Systems with Structure, that is inspired by a few colleagues' talk about event-driven systems with Quarkus, Apache Kafka, and marshmallows. It had been broadcasted via Red Hat so far, but since it becomes not available after a year in the system, by getting the right permissions from Red Hat marketing folks, I thought it would be great to share it with you via my own YouTube channel, System Craftsman. So make your popcorn or your marshmallow ready to visit the event-driven coffee shop, and I hope you will enjoy it. Also, don't forget to like the video and subscribe to my channel to support my work. Hello everyone, welcome to the A Day in a Coffee Shop webinar. Today we are going to talk about event-driven systems with structure. My name is Aykut Bulgu. I'm a content architect at Red Hat Global Learning Services and served many years as a consultant here at Red Hat as well. So I will guide you through this webinar, which is based on the AD 482 course that will be available next month. Today we are going to learn about HTTP request-based architecture and its drawbacks, event-driven architecture with Red Hat AMQ Streams and how it solves problems by reducing the coupling between services, schema types like JSON, Protobuf, and Apache Avro, and contract-based architecture with Red Hat Service Registry and its capabilities. But first we have to visit the coffee shop. Getting bored of the lockdowns and pandemic that has been around for a while, and with the arrival of the summer, you want to chill out at somewhere and you will find the coffee shop nearby your neighborhood. You go and sit somewhere. The place looks peaceful, but baristas seem to be a bit tired and overloaded. You wonder why. But anyway, you want to order your cappuccino. So let's order our cappuccino. This is our coffee shop system, and you can simply write your name here and select your beverage from here and place your order. So let's write our name, and I will drink a cappuccino. Let's place the order. Okay, that's ready. I want to order another cappuccino after some time. Oh my god, it fails. Let's place an order again. As you can see, sometimes it fails, sometimes it's successful. I wonder why this happens, so let's go back to our coffee shop. When you ask this to the barista, she simply says, "We have a preparation time around 5 seconds, but this coffee shop has strict rules on preparing the beverage in 1.5 seconds. So I have to either prepare it in 1.5 seconds or never. If so, you have to order again." Notice that the coffee shop system basically works with a HTTP request-driven architecture that is a lot error-prone. But what is a request-driven architecture and why it may be so problematic for some use cases? Request-driven approach is a very common approach while developing web services or microservices. REST over HTTP, gRPC, RMI for the Java world are examples of these. REST is very popular since it's been used with SOA architectures and microservices as well. Queries are used for the data retrieval, which is synchronous, and commands are the calls for the remove function over the API as a post maybe in a REST-based system, for example, to get the job done. However, request-driven systems has some drawbacks. While latency is the key point for a synchronous communication system, in a request-driven model is strongly tied with the performance. These performance and latency problems can cause availability issues, especially in a service-based system because data relation between services are tight, and this tightly coupling gets worse when a system grows. Especially for microservices, these availability problems can be solved by fault tolerance mechanisms, but neither HTTP nor other request-driven approaches has a built-in fault tolerance mechanism. And it's not a solution for the data coupling because fault tolerance systems generally have fallbacks with the mock data. Switching back to our coffee shop, the coffee lovers create their order on the coffee shop system over HTTP, and all the orders are taken care of again over HTTP by the baristas. Because of the 1 to 5 seconds capacity of the baristas, which is strongly related to their performance, and the coffee shop limitation for 1.5 seconds, which works like a limited fallback mechanism, causes the failures and the overall latency. With the current approach for a barista, there is no way to get the order event data again and update it after a failure because once it's processed, it's done. There is no way to replay and reprocess the same order. So in this current system, if one of the services have a failure, it directly affects the others because of the data coupling between. In this case, it's orders and beverages. So who are going to call for fixing this problem? Ghostbusters? AT? MacGyver? That would be cool, by the way. Well, the door of the coffee shop is opened mysteriously. A man wearing a red fedora walks into the coffee shop and sits beside you. He will introduce himself later as Mr. Kafka. He orders a coffee, but he faces the same problems. It's the third or fourth time he can order his espresso. So knowing how to solve this problem, he calls for the coffee shop manager and starts to tell about his plan. But first, he needs us to know some concepts. Event-driven architecture and messaging. Event-driven architecture is a software architecture and model for application design. With an event-driven system, the capture, communication, processing, and persistence of the events are the core structure of the solution. This differs from the traditional request-driven model. And event-driven architecture is loosely coupled because event producers don't know which event consumers are listening for an event, and the event doesn't know what the consequences are of its occurrence. For this, an event backbone is used at the center of your architecture to flow the events for all around the system. These events can either be for notification or state transfer. In our coffee shop, events will be used for the state transfer, which is the state of the orders and beverage queue data. Coffee lovers will make their request with HTTP to the coffee shop, and each order and the selected beverage will be written in the event backbone to be processed by the baristas that are subscribed to the same event backbone. One of the most used event backbone mechanisms nowadays is Apache Kafka. So Mr. Kafka suggests us to use AMQ Streams. If we take a quick look at how Apache Kafka works briefly, producers create messages and consumers consume those messages, and even if those messages are consumed, they can be replayed and consumed again because Kafka stores those messages for a specific configurable time. So this creates a great advantage for an event-driven system because if an event cannot be transferred somehow, messages can be easily replayed and the related event can be consumed successfully with an at least once delivery strategy. Red Hat has three Kafka options. One of them is the AMQ Streams on RHEL. That is a fully supported release of Apache Kafka that runs on RHEL. AMQ Streams on OpenShift, which runs as a Kubernetes operator to manage Kafka objects, including the cluster. And OpenShift Streams, which is pretty new, that provides a fully managed Kafka instance for the end users, so that users don't have to deal with cluster management, which is cool. AMQ Streams on OpenShift structure is basically like this. It's based on the upstream project StreamZ, which provides a great Kubernetes operator to manage the clusters, topics, users, and the many other Kafka relevant objects like, for example, Kafka Connect. So let's return to our coffee shop application and make the changes regarding the new architecture as proposed by Mr. Kafka. So this is our Kafka cluster up and running in our OpenShift cluster. It's provided by AMQ Streams operator. We are gonna use this for this demo as an event backbone. So going back to our code example, this coffee shop service, we have a few services here. We have the coffee shop service. We have the barista Quarkus HTTP, which served us before, as you can remember, in HTTP method. And we have this new barista Quarkus Kafka, which will process things differently. But we have to change a few things, like first let's go to in order to make this a messaging application from now on, we have to do some things in this exercise. You can find the solutions in the same repo, by the way, but let's do this together. So first we have to add the reactive messaging and reactive messaging Kafka libraries of Quarkus that is provided by SmallRye. So since we have two of this, let's go to our we have a Java resource. It's called coffee shop resource, and it's the resource that we used before for HTTP. So here we have to add another post mapping for messaging, or with another path. You can add it with another path. I know it's not a good naming, but let's add this post mapping here that emits and sends some data to orders and queue channels, which has an equivalent of which is an equivalent of a topic of two topics actually, called orders and queue. We will be creating those in a minute. So now we don't have we don't see this because I didn't update the Maven after updating the POMXML. So let's update the dependencies in the meanwhile, and we need to have this create beverage in queue, so it will just create a beverage with the state in queue. So before the processing by the Kafka barista, it will be the state will be in queue. We will see that. So if it is updated, let's import those in a very quick way. I think that's, oops, sorry. I think that's okay. So what we are doing here is we will, when we click on the order button in the front end, it will send the order object here. We will set an order ID, and we will send these to both beverages and orders topics to be processed by the baristas. So the next thing we have to do, we didn't configure this application to use any Kafka or messaging. So let's copy our properties here. this part is about Kafka. We have the Kafka's public URL here, which is in our OpenShift. So this is the root URL and it's HTTPS. So we have to specify this, tell this to client, Kafka clients that this uses a SSL protocol. And if we are using an SSL protocol, we have to define this trust.jks file and its password. I created those upfront in my example, but it's not included in Git repository. It's in the Git ignore. So you have to run this get keys. It will extract the public certificate from the cluster and convert it to a trust.js so that you can actually any client can access this Kafka healthily. After that, we have the MP messaging outgoing for queue and orders, and as you can see, it has those JSON-B serializers because the data will be produced to the Kafka topics, and those should be in a JSON format in this case. And for this incoming one, it's the beverage deserializer. After the barista takes care of the order, he or she will send it to the topics, the queue topic again, and we will take that from the queue topic and show it to you. Show it in the coffee shop service frontend. And for that, we have this beverage deserializer. So yeah, since this part is okay, let's switch to our Quarkus Kafka barista, sorry, and we have to do pretty much the same. Let's go to the service and we have the prepare method, as you can see. So I'm adding this in order to get the incoming orders and process them and put them into the queue again to be processed. So the coffee shop service and the barista use this queue to keep the last state. Actually, the coffee shop uses this queue. Orders are imported in terms of for the baristas because they will take the order, they will prepare the beverage and put it into the queue so that we can update the state. So let's, before that, yeah, we have to add this dependencies as well here. I always forget that. Oh, not here, sorry, in the POM XML. Let's add those also and go back to our Java class. In a minute it will be updated. I can see it here. So yeah, import those, import outgoing, incoming, and this blocking to block. So yeah, I think that's fine. And we have to, in the same way, let me check my notes for this because I don't want to do any mistakes. We have to again set the application properties configuration here. As you can see, this is the same. In this case, orders is the incoming because for this barista, he or she only takes care of the orders, nothing else. It's like a barista microservice. So, and for the outgoing, it should be definitely the queue and it should be serialized in JSON-B, in JSON again. And for this, we have to deserialize the order. So that's why we are using this. So one other thing we have to do, we have to create these orders and queue topics. If we don't do that, Kafka on OpenShift will take care of that, but I want this to be done in a proper way because it will automatically create one partition, one replication factor topic. So these are the commands that belong to Streamz Kafka CLI, an open source project, and this open source project is created for an imperative approach for Streamz operator. So if you don't want to create YAMLs, normally you should create some YAML resources to create topics and other stuff. For an imperative approach, because it's easier, I use Streamz Kafka CLI without dealing with any YAMLs. So let's actually run this create topics sh here. There are many other topics, please ignore them. I'm using this Kafka cluster for other purposes as well. Yeah, the orders and queue topics are created, so here they are. And we have the 4 partitions and 1 replication factor. That's cool. So let's run this. First, run the coffee shop service. I'm using the IDE for this because it's more visual for you, and I think it's better for you. But you can run any Quarkus application with a Quarkus run command with a Maven command. I mean, so feel free to use in that way. I'm running my coffee shop service. In the meanwhile, I'm checking my notes. That all should be okay. Yeah, it seems that it's connected to the Kafka, so that's good news. I will go to localhost 8080. This is our coffee shop. Now we have this order method messaging Kafka. I updated this for you in this branch so that we don't have to deal with the front end, but it's in there. You can always check it out. Let's say again, that's me. I'm ordering a cappuccino. Okay, that's good. It's in queue because we didn't start any barista yet. Let's say I order some other stuff. Yeah, let's try some espresso. And let's say that since we are doing this with Mr. Kafka, he likes chai, and let's place an order for him as well. So that's cool. Now all the orders are in queue, so let's start. Okay, we will wait a couple of minutes. You can go and get an actual coffee, by the way, instead of the virtual ones. Okay, it is starting. Okay, it all starts, so let's wait because they will start, they will connect to the Kafka cluster, they will, yeah, it began. Okay, 2 of them are taken care of by Zoe, and 3 of them are taken care of by Ivy. That's great. So what happened here is we have a Kafka as an event backbone, and we have 2 topics there, and one for the queue and the other one is for the orders. We create our orders from the front end, and those go into the produced into the orders and queue because it has to be shown to us. And the barista consumes the messages from the orders, change the beverage state and or order state, and pushes it into the queue topic again. So This is a kind of a event-driven approach, and in this case, events carry the states together. We have the order state, we have the beverage state. We are carrying the states. So let's go back to our coffee shop. So everybody becomes happy with the changes. Baristas can go for a rest now, and when they come back, they can take the orders from where they left. The limitation of the barista capacity is no more a bottleneck, and the limitations of the HTTP request-driven system is not a problem anymore because the coffee shop has now an async event-driven system that keeps the orders in the event backbone and processes them one by one with the barista services. Well, every good thing lasts some time later. While everybody is happy with the new system and happily drinking their coffees, beverages, an uproar has started at the outside of the coffee shop. A giant marshmallow man is walking between the buildings and breaking things unintentionally. People are screaming, yelling, escaping from the marshmallow man. Well, he's good in a way, but has to be taken care of. So, well, you know the rest of the story. The guys with the white car and weird jumpsuits come to rescue. They fire their beam guns to the giant marshmallow man, and the marshmallow man blows up and literally everywhere becomes melted marshmallows, including our coffee shop and the internals of the coffee shop and the coffees, unfortunately. So this means that we have to drink our coffee with marshmallows from now on. Let's do the change. In order to do the change, I checked out exercise messaging marshmallows branch in the same repository, so you can do the same. And we will add some marshmallows into the order. This is the coffee shop service we have just changed for messaging capabilities. So let's add a marshmallow has marshmallows through here. By the way, in this branch I added this has marshmallows field both for order and beverage, so you don't have to do anything related to that. So it's enough for you to just set the marshmallows through here, and it's set to true, and we don't have any other choices because everywhere is in marshmallows. So let's go back to our coffee shop. So let's go back to our service and start the coffee shop service again. And I will start one barista service when it is up. It seems to be up, so let's start a barista service as well. I've made some changes also in the front end so that we can see the marshmallows field, as you can see here. So okay, let's create our order. Let's say that again, a cappuccino. I place my order and it should be in marshmallows. It's in queue, but as you can see, it's not prepared with marshmallows, even if everything is in marshmallows. The barista, in this case Jack, couldn't understand that field. So I can go to the barista Quarkus Kafka service and make the change, but every time I have to do this. So and think that these services, the coffee shop service, the barista service, are taken care of by different teams. So that would be hard, even if they are not taken care by different teams. There should be a common thing, a common contract. Now let's go back to our coffee shop, and our coffee shop manager will explain this better. Talking to the coffee shop manager, he says there is no contract between the shop and the baristas. So even if now there are marshmallows automatically included in literally everything, you have to agree upon a contract that tells the baristas about marshmallows. Mr. Kafka says he can help us with this as well and brings up a parchment from his jacket pocket, and while writing some stuff on the parchment, he started to explain what kind of a contract he is preparing. Schemas as the contract. A schema is a blueprint for the message or the event. It defines what data should be in there, what different types of data structures available. Schemas are not new. They are pretty much used for the APIs in the Open API or XMLs have their own schema files called XSDs, which define the XML structure in that case. So messaging systems has their own data schemas. We have JSON schemas, Google Protocol buffers, which is also called protobufs, and one of the most common ones, Apache Avro. Producers and consumers need to be preferred schema structure for the particular object so that a serialization or deserialization can be done to transferring the event messages. Once Mr. Kafka prepares the contract, he says it's an Avro schema so that they will need to serialize and deserialize the relevant objects with an Avro serializer. He adds that the contract must be accessible from both the baristas and the coffee shop system, so it should be somewhere common that every stakeholder can reach out. This brings up the schema registry topic with the Red Hat Service Registry. Red Hat Service Registry is based on the upstream project Apache project. It's not only designed to be a schema registry but also an API spec registry, or can be used as a shared data type store. For the schema registry, it supports the Apache Avro format, JSON schema, and protobuf formats. Red Hat Service Registry can store the schemas either in Kafka topics, or PostgreSQL database. So when a producer wants to send the data, it's serialized first regarding the type of the schema used and queued in Kafka. Then a consumer deserializes the data after the consumption again with the knowledge of the schema by getting it from its ID from the service registry. So with this way, the schema registry runs in a common place that any of the clients that will use schemas can easily reach out and agree on the schema like a contract that is hung on a public wall. So with Mr. Kafka's help, a contract is hung up on the wall so that all the stakeholders within the coffee shop can access it and agree on what to serve and how to serve. Now let's make our changes regarding the schema registry and the Avro schemas. For this exercise, I checked out the exercise marshmallows branch in the same repository so that we can make our changes here. First, let's start with the dependencies. In this coffee shop service, we need to add a few dependencies regarding Apache registry and Aura for the Quarkus. So I will put these dependencies here. One is for the Apache registry uses SERDE. It's for serialization and deserialization that we are gonna use in our property configurations in a minute. And the other one is for the Quarkus Aura. So since we said Aura, we have to have some Aura schemas. Now we will create those schemas. Let's go to our src main. I created a folder called Aura here, and Aura files, Aura schema files should has this extensions AVSC. So let's first create this beverage SVSC. I will copy and paste it. Our schema is in JSON format, but in this JSON you define the our schema's name and type and namespace. In this case, this is the namespace, so that it will be created in this namespace, but we have to do a few things to generate this generate objects from the schema in order to use them. And we have some fields like we have beverage, customer, prepared by the same fields that we have as marshmallows. These are the same fields that we have before in our messaging exercise messaging branch. So feel free to compare them. And let's also create the order schema as well. So this is the same. We have product, name, order ID, and has marshmallows again as boolean. The others are strings. So yeah, in order to create these objects from the schemas, we have to add this Maven plugin in our POM XML, so that we will be able to generate those plugins here. So let's add our plugin here. This is the plugin that I just add. It's the our Maven plugin, and with the generate sources command, we will be able to create a set of objects, in this case 2 objects, one for beverage, the other one for order. In the build directory, this is the target, and in that target, generated resources. So let's save this and go into coffee shop service, and let's generate our sources. So I will run generate sources. Yeah, now those objects are generated here. You can generate those in anywhere, by the way. I wanted to generate those here because it's a generated code, and it should be in a target. It should be near the other generated resources. So yeah, as you can see, we have the beverage, we have beverage state, we have order. All of them are auto-generated by our Avro Maven plugin, so that we will be able to use objects, Avro objects here. A few things we have to do, as you can guess, we talked about serialization and deserialization. So let's go to our application properties, and we have this JSON B serializers, as you can remember. So we have to change those to our Kafka serializer. So let's make the change. This should be our Kafka serializer. The other one is again the same, and this also should be an our Kafka deserializer, because we have to deserialize object that is incoming. Okay, so let's remove this so that okay. And if we have a few other things, like we need to set our Apache URL. By the way, our Apache registry is also up and running in our OpenShift
here it is, and we have this root for that, so we will access this Apache registry directly from here. So the URL is the same, but at the end we have to provide the API URL like this. So the other properties here, like we could define this one time for all, but I prefer to do this for each of the, for the orders, for the queue, for beverages. It's all the same. One is the artifact ID, it's the topic ID strategy. The other one is the global ID, get or create ID strategy. These are strategies, these are different strategies that belong to Apache registry. And reflect our datum provider. This is for our datum provider reflection. So these all are these all can set like this for all of them, but I prefer to do this because this can change per per topic, per object. So let's go to our Quarkus Kafka and do the similar things here, like at the Auro dependencies and Apache dependencies here, and by the way, let's go back here and make a Maven update here. Here we need to do the same. We will do that in a minute. We have to also define the schemas here. This is for beverage. These all are the same, by the way. I could skip those, in fact, for this, but I just wanted to make sure that you understand the process, because there is a contract. There will be a common contract, by the way. We are generating the schemas locally, but in the end there will be a common contract in somewhere common in the Apache registry, so that they will be able to, these clients, these services will be able to talk in the same language. So let's again generate the resources, this time for where's the Quarkus Kafka generate resources. Okay, one more thing, we have to define this serializers and deserializers for this one as well. I set the other properties here in order to be faster. So this is the, oh sorry, this should be the serializer for the outgoing queue, and we should define the deserializer instead of order deserializer that we used before. Okay, we set the same Apache URL here, and others are the same. That's good. Now let's go to our services and run coffee shop service first. And after running those, and when we make sure that all works properly, I will show you the Apache registry and the contracts created regarding this schemas inside. Let's go back to our application and try. Okay, it's down for now. Okay. Okay, it seems to be up. I think it's, we can check out the logs, but pretty much small here, so it's better to just check. Okay, now let's say in this case and hot chocolate here, place order. Okay, that's in queue. Let's go back and run one barista service, let's say. Now it's up, and let's wait for it to be prepared the beverage. Okay, it's ready, and we have marshmallows in it. Great, hot chocolate with marshmallows. I will be in a sugar coma, that's for sure. So when we check our Epicure registry, let me refresh it. We can see both schemas here as beverage and order. This one is for the queue, and the other one is for order. If we check out the content, you can see it's the same schema that we created, and has marshmallows and other preparation state stuff. It's the same for the order, so it has these values again, marshmallows. So if we change any value here from now on, let's actually break some things. Let's actually break some stuff here, like let's say let's break some Q stuff. We have the latest version, and it's the same version, and I will now update this. I will delete, for example, a field from here. Update new version. You can browse a file and a AVSC file and set it here, or you can just copy and paste stuff. By the way, let's change. Yeah, let's delete marshmallows here, so that we'll make sure it won't work without this agreed contract. So let's upload. Okay, now we have the second version, and if we check it out, we don't see any marshmallows here. Let's go back to our queue, but let's first check out our services. They seem to be running, so I will refresh this just to make sure. Let's order for a chai this time. Yeah, as you can see, it doesn't work because the coffee shop and the baristas has this contract between. So let's fix things, go back, and let's check out the first version. I will copy this and upload this as a new version this time. Go back and place an order again. And as you can see, it works now. So we make sure that all the coffee shop stuff, including manager, baristas, and the coffee shop system itself, agrees on this contract, and if this contract changes, they have to change their code. Yeah, this concludes our exercise. So that's all for the demo, and thanks for listening, and thank you joining this webinar. You can find all the resources in this repository, including the code and the resources that are used. Please take a screenshot here if you like. And if you are interested in the full training, developing event-driven applications with Apache Kafka and Red Hat AMQ Streams, well, that will be available next month, but the hands-on labs are available now in the Red Hat Learning subscription. So feel free to check it out. So thanks again. If you have any questions, please feel free to ask. Thanks for listening.